All right, let's take a look at writing these in radical form. These are expressions where you see an exponent that's got a fraction. Looks kind of daunting. So let's see how we're going to do this. Okay, so first thing I would say is this is the way I remember it. I think about something like x to the 1/2 power is the same as the square root of x. So how can I use that to help me here? Well, this x, if I had to put an exponent on it, it would have to be 1 because if something doesn't show an exponent, it's just understood 1, right? So the 1 must be what goes here. The top number goes here with the variable or the number or whatever. And that bottom number is the number out in front. Now, radical is the only time in math that I can think of where there's an understood 2 in a problem. We don't see that. We see understood 1s where it's just understood that there's a 1 in a place, but having an understood 2 is kind of interesting. So if it's in the denominator, it goes here. It's called the index. It's just a little number outside of that radical. So I'm going to use that to help me with this. I know that I'm going to have a radical with 2 under it because 2 is the base, right? And so the top number goes with that underneath. So the top number 7 is going to go under here, 2 to the 7th. And that means the 4, just like this 2 is understood, the 4 is going to go out here. So this is saying the 4th root of 2 to the 7th. Now, if all you have to do is write this in radical form, then you're done. Like that's your answer. Or you might see it as the 4th root of 2 raised to the 7th power. You'll see it kind of both ways. Okay. So if all you have to do is rewrite it, then that's all you have to do. You're done. That's your answer, whichever way makes more sense to you. But if we're going to simplify this, if we can. So I'm going to use this one. This makes more sense to me in terms of like what this is saying. The 4th root means, you know, like in the square root, you're looking for groups of 2. Like if I do, let's say I'm doing the square root of 25. Well, 25 is 5 times 5. That's a group of 2. So I know I'm looking for groups of 2. Remember that little index understood is 2. I found a pair of 5s. The square root of 25 is 5, right? A pair means this is a perfect square. Okay, so I've got 5 there. So I'm looking for groups of 4 here. Well, 2 to the 7th means 2 written 7 times. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Okay. Whew. All right. 2 to the 7th is 2 times 2 times 2 and so on. And I'm looking for groups of 4, whereas I circled a pair. Now I need a group of 4. So that I've got one group of 4 there, and then 1, 2, 3. Okay, I don't have 4 more. So I'll stop as far as like circling. Nothing else to circle. So that group goes out in front as 1. So there's 1, 2 that comes out, just like there was 1, 5 that came out of our circle there. And we still have the 4th root of what's left. 2 times 2 times 2. We can simplify that. What is 2 times 2 times 2? Though that's 4 times 2, which is 8. So 2 times the 4th root of 8 would be the simplified version of 2 to the 7/4. Okay. See if you can use that to help you do 3 to the 3/4 power. And so you can pause and then come back to it. All right, same idea here. I know that the top number is going to stay with the thing that's underneath. So I know this is a base of 3, so that's going to go underneath. The top number is going to go with it. And then the bottom number is the little index or the number out front. So again, we have a 4th root. Okay, 4th root like before. And again, you could also rewrite this as the 4th root of 3 raised to the third power, right? You can have it like that. Okay, those are the same thing, same idea. That is a 4. Okay, so think about this. This is the fourth root of 3 times 3 times 3, 3 to the third, right? I'm looking for groups of 4. There is no group of 4, right? So the only simplifying I could do is just to multiply that. I could say 3 times 3 is 9, times 3 is 27. So the fourth root of 27. But if you can't really simplify it, then this is actually good. This is fine to leave it like that. So, all right. Not easy, but doable. You can do this. Okay. Being determined to stay with it and to learn it, that's huge. And you've stuck with me this long. You're pretty determined, so that's good. All right, see you next time.